Finally, we can set up the last option called connections. Press the wheel on connections and choose switch, and we choose setup. This is where we set up the use of the 0 to 10 volt output that the SYX controllers offer. There are 3 options. The first option is whether we use it for controlling the variable temperature valve as a 0 to 10 volt signal. The controller naturally offers a drive open or a drive closed signal, which is the majority of products on the market that the SYX replaces. However, there is the opportunity to replace more sophisticated products with the SYX, where you're looking to offer a cost saving to the client, which means we can utilize a 0 to 10 volt drive straight out of the box without any settings needed. The 0 to 10 volt can also be used, as we've already discussed, it can be used to drive a Boiler Pro sequencer, in which case we would choose the boiler percentage option for the 0 to 10 volt output. That could also be used to drive a boiler directly. We don't have to use a sequencer. That would only be for multiple boilers. If there was one boiler that could accept a 0 to 10 volt signal, we could drive that boiler directly, just using that as a demand signal. Equally, if the boiler is compatible with it, we could send a 0 to 10 volt signal as a boiler set point, where we can scale the 0 to 10 volt output to be reflective of the actual flow temperature demand. So that's another unique feature of the SYX product in this category of products on the market. So if we do choose boiler set point, we do need to be able to scale the output, and that's what we do in the values section in the setup menu. So we choose escape, 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 this time choose values, and this time we choose setup, and this is where we can scale the output. Where it says output, that's the current voltage reading. Set point low and the minimum voltage go hand in hand. This is where we set the expected set point minimum for the relevant voltage, and we also set the set point high with its relevant voltage. In terms of percentage, 100% would be 10 volts, 0% would be 0 volts. Okay. To finish up on connections, we also have sensor calibration, where if you identify that a sensor is a little bit inaccurate, you can apply an offset to the reading. It's a linear adjustment. It's a single point adjustment. So for example, the outside air sensor was reading ½ degree too high. We can knock that back by 0.5, and that will be a permanent offset onto that sensor as part of your final commissioning or maintenance of the product. Okay, and we didn't finish in switch, where we have pump changeover modules. If pump changeover modules are being used on the outputs to drive twin head pumps, it's important, one of the important features is that those modules are turned off as a demand signal in order for the lead pump to change over, subject to them being in fault. So for an automatic changeover, the module needs to have its demand signal removed for more than 15 seconds. If the SYX is in an application where the heating is 24/7, subject to some kind of economy mode, it could be like a retirement home or like a fire station where it's manned 24/7, we only relax the heating back, we don't actually turn it off, then we have to find a situation or engineer a situation where we actually remove the demand for the pumps for a short period of time, 15 seconds, so that the pumps can change over on the changeover modules. Okay, so that's what the pump changeover module menu will do. It will allow us to rotate weekly or daily, and that's what it does. It disrupts the pump demand signal for 15 seconds so that the pumps can change over. We're going to be leaving that as not used at the moment. Okay, so that concludes all of the menus that we need for the setup mode. So what I'd like to do now is take the opportunity to show you a few things that the controller can be used for in terms of helping you to commission the product. So the first thing I'd like to touch on would be just to escape out of the product, get back to the time and date, where we have the information button. We can press on the information button and choose terminal values, and this gives us a live display of all of the inputs and outputs on the controller, so we can identify If, for example, a particular item of plant isn't working, it could be a wiring issue, it could be a power supply issue, it could be a piece of equipment issue. But if the controller is asking it to run, but the plant isn't actually running, you can focus your attention onto the item concerned rather than focusing too much about the controller. So it's a good point to start is just look at the pins, see what the current condition is before you start to get too involved in trying to work out why things are or aren't working. Sensors, all the sensors should be reading, obviously the ones that are connected. For certain applications we need certain sensors connected, so just make sure that they're all wired in correctly. Some of the controllers types do have polarity sensitive sensors, so the SYX66x product, the sensor connections are polarity sensitive, so you must observe the correct connection of the sensors. All the other controller types are not polarity sensitive, and it doesn't matter if they are incorrectly wired. There's no damage you can control to the actual sensor inputs by wiring them around the wrong way. Obviously, just make sure that they're all working prior to powering up the controller's outputs in terms of the mains voltage signals. You don't want to make sure that all the wiring is correct before you permanently power up the device, especially with mains power on the outputs. So, okay. Next thing I'd like to show you is how to test the variable temperature valve. Again, we're still logged in at user level 2, and for that we can make a manual override adjustment. So we press the select button, we choose heating, we choose values, and we drop down onto the VT valve, and we press on the wheel on the VT valve and we choose manual override. Press the wheel on manual override and it gives us the option to put a value in there. So I don't know, just arbitrarily put 60%. The hand light has come on and the outputs have started to drive the valve. We can then visually check the valve is driving the correct direction, make sure the valve is correctly allocated into the pipework, and then once we're satisfied that everything's okay, we can press the select button on the valve on the manual override parameter, and then we delete the value. We wait for the hand light must be extinguished before we'll get auto control. Okay, so that's complete. Press escape. Another nice feature of the SYX controller is the commissioning mode. Now, it's a common factor that a lot of heating controllers are installed during the summer months. This is where the plant is of no use, is in a maintainable condition, maintainable state, should we say. So during the summer months, most of the boiler houses are being refurbished or controls are being upgraded. So during those summer months, it's the last time of the year where we actually want to have the heating running. So we have to find a way of making the plant work so we can actually test the plant. So having the commissioning mode is really, really handy because we don't have to over manipulate the controller to make it operate, because a heating controller will fight us trying to make it run in summertime. So the commissioning mode simulates a winter's day, and to put it into commissioning mode, you press the select button, you choose heating and switch, and you choose, in that list you then choose commissioning mode, and then you turn the commissioning mode on. The hand light will come on and the display will start to flash at you to say commissioning mode is active. Now what that actually does, if we come out of the switch function and go back into heating and choose values and then look at temperature control, if we just scroll down the list of values there, the outside air temperature is now simulated as being 5 degrees and the space temperature is now simulated as being 18 degrees. Now that means that the controller will think it's a very cold day and it thinks it's cold in the room, and it will mean that the heating will come on and it will try to achieve a set point of around about 70 degrees depending upon what the current room temperature is. There you go, flow set point 70 degrees, and then we can see the valve modulate, we should see the boilers come on, we should start to see the controller start to control the flow temperature around 70 degrees. And that's a good way of proving that that particular circuit is then going to be fed with the flow temperature we expect into that particular zone of the building. So what I would then do is go and inspect the radiators in that circuit, make sure they're getting warm, especially warm where the room sensor is located. It's essential that the placement of the room sensor is in a heated location in order for the optimization to function correctly. And we want to make sure that those TRVs are turned up to maximum, and we want to make sure that that flow temperature is actually being sent and received at those radiator locations. Okay, that's about it for now. One other setting I just want to point out is the warming up rate of the heating system. So to get to that, we choose the switch, we choose heating, we choose values, we choose temperature control, and we just scroll down and we choose the warming up rate, building warm up rate. Hit the wheel on that, and you can see on this particular controller it's been set to 1, probably from a previous video that we've been preparing on this particular product. And this is where we set the building warm-up rate, and we can adjust that, and we can make the necessary changes to clear the building warm-up alarm, optimize a low limit alarm that we've discussed in a separate video. But this is where you can make the same change for the same reasons and remove the alarm from the system as necessary.